Texan Global School, Parallelism and Perpendicularity. In this class, the conditions of parallelism and perpendicularity between two lines are analyzed. Given any two straight lines, L1 and L2, in the plane, they are parallel if the angle between them is 0 or 180 degrees. We will make the deduction to prove this statement using the formula to obtain the angle between two lines, analyzed in previous classes. Since θ1 is equal to 0 degrees, the left member is equal to 0 by substituting into the formula. Recalling earlier classes on exact values and trigonometric functions, the tangent of 0 degrees or 180 degrees equals 0. Then the denominator is eliminated by multiplying by its multiplicative inverse, or simply, since it is dividing, it multiplies the other member. Therefore, the slopes m1 and m2 are equal. So we conclude that two lines are parallel if their slopes are equal. Now, let us make the deduction to show that two lines are perpendicular if the angle formed between them is 90 degrees. We will use the same formula to obtain the angle between two lines. Since θ1 is equal to 90 degrees, by substituting into the formula, the left side does not exist. Remembering previous classes of exact values and trigonometric functions, the tangent of 90 degrees is 1 over 0. Graphically, it is an asymptote. Hence, we will have to use the reciprocal of the tangent. Therefore, the cotangent of 90 degrees equals the reciprocal of 1 plus the product of the slopes over the difference of the slopes. Using exact values, the cotangent of 90 degrees is 0. Similarly, the denominator is eliminated by multiplying by its multiplicative inverse, or simply, since it is dividing, it multiplies the other member. Therefore, we conclude that two lines are perpendicular if the product of their slopes is equal to -1. Let's see a first example. Prove analytically that the lines L1 and L2 are parallel to each other. The points 1, 1 and -2, -2 belong to the line L1. The points -2, 1 and -3, 0 belong to the line L2. First, graph the points. As seen, two lines are parallel to each other if their slopes are equal. So, calculate the slopes of both lines given 2 points using the formula analyzed in previous classes. For L1, its slope is equal to 1. For line L2, its slope is also equal to 1. Graphically, we can see that the lines are parallel, and analytically, it is also demonstrated since the slopes are the same. In this other example, prove analytically that the lines L1 and L2 are perpendicular to each other. The points 2, 5 and -3, -5 belong to the line L1. The points 2, 4 and 0, 5 belong to the line L2. First graph. As discussed earlier, two lines are perpendicular to each other if the product of their slopes is equal to -1. So, calculate the slopes of both lines given 2 points using the formula analyzed in previous classes. For L1, its slope is equal to 2. For the line L2, its slope is equal to -1/2. If we perform the product of its slopes, results -1. Graphically, we can see that the lines are perpendicular, and analytically, it is also demonstrated. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com